Which of the equations are equivalent to the following equation? A capital letter represents a matrix and a lowercase letter represents a scalar. Assume that the matrices are all square. Fair enough. So the equation here is the matrix B times the matrix A is equal to the matrix D. All right, so let's think about which of these are equivalent for all square matrices B and A. So here they've swapped the order A times B, and we've already seen multiple times that matrix multiplication is not commutative. It is not always the case that B times A is equal to A times B. So we can rule that one out. Here they keep the order. They have the B times A, they have the B times A, but they've introduced a scalar out front. They're multiplying the scalar times B and then multiplying that times A. Or actually, we could do it in multiple different orders, as we'll see. But just to show that this is the same thing as D, let's do an example here. And we'll do it with 2 by 2 matrices. And obviously, this isn't a proof. I'm only showing it to you for the 2 by 2 case. But hopefully, it gives you a little bit of confidence here. So if this is B1, B2, B3, and B4, and this is A1, A2, A3, and A4, we know what this product is going to be. We know what D is going to be equal to. It's going to be equal to, I should probably have some more space than that. It's going to be equal to B1A1, B1A1 plus B2A3 plus B2A3. I'm going to run out of space here. I can already see that. So let me actually clear that. And I'll write the next one in a color that I can see on white or black. And we know that this next entry over here is going to be B1A2 plus B2A4, B2A4. And then this entry is going to be B3A1, B3A1 plus B4A3 plus B4A3. And then finally, this last entry, second row, second column, B3A2 plus B4A4, B4A4. So that's what the product is equal to. And I'm sorry for having to switch contrast right over here between the white background and the black background. But let's imagine what happens if we introduce an R. If we introduce an R right over here, then multiplying this B times R is equivalent to just taking the R and multiplying it times each of these terms. And if you did that, that's equivalent to taking every place where you see a B, you're just multiplying it by an R. There's an R there. 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 Now, this is clearly going to be the same thing as R times our matrix D. Our matrix D was what it looked like without the R's in it. If you multiply it times an R, you're going to get this thing right over here. So hopefully this makes you feel pretty good that this statement right over here is true. Over here, this next one, once again, they still have B times A, but now they're multiplying A times R. And for the exact same argument, for the exact same argument, actually let me go back here and let me recheck the ones that I've already checked. So we know that this is true. Now for the exact same argument, if you multiply A times R, you're going to have R, 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 R. And so every place where you see an A, you're going to have an R in front of it. So R is all of these places. So by the exact same argument, the scalar being multiplied after the R. So notice, we're not changing the order of the matrix multiplication. It's still B times A. But the scalar can come before the B, or it can come after the A, or we can multiply the scalar times the A, and then do B times that, AR. So, but this is equivalent. Now here they're taking R, and it's A times B. So they are fundamentally changing the order of the matrix multiplication. Matrix multiplication is not commutative. So we can rule this one out. Now this one is interesting, RB times RA. So let's think about it. So this is B, this is A, this is D. Now let's think about what happens if we put R times B is going to be, we're going to see R's all of there. R times A, you're going to see R's over there. And then, so for example, this term right over here is going to be RB1 times RA1. Well, that's going to be R squared times B1A1. And I apologize that it's kind of getting a little messy right over here. And then the second term is going to be RB2 times RA3, which is going to be R squared B2A3. And we keep going. We're going to put an R squared in front of everything. So this is going to be the same thing as the scalar R squared times the matrix D. So that is also true.